Okay, so we're going to take a look at this problem, which is kind of broken down into a couple of steps. But what we really want to be interested in first is making sure that we graph our polygon correctly, and then we want to make sure here that we are labeling our points. Because in the regions, if it says state a point, you want to make sure that you have the letter as well as the coordinates. Okay, so if you see the word state on the regions in particular, you want to have the letter as well as the coordinates. Okay, so pay attention to detail. It's kind of clutch on this one. All right, so the first step is we've got this polygon that's graphed, BIRD, and what we want to do is prove that this polygon BIRD is a trapezoid. Okay, now on the back of the sheet, you can kind of see, to prove that something is a trapezoid, you must show exactly two sides are parallel, and then parallel segments have the same slope. And calculate all four slopes using that. Okay, so we're going to go ahead and we're going to calculate all four slopes here. All right, so the first thing that I want to do is I want to take a look at this slope here. What's this? Rise. What's that? Run. And then look at this one. Rise, run. Then look at this one. Rise, fall. And look at this one. Run, rise. Okay, so let's take a look at B to I. So when we're going to look over to B to I, what are we counting here? So if I count from B to I, I'm going to count up 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4. So the change in the Y is 6. The change in the X is 4. Simplified would be 3 over 2. And then I'm going to look from I to R here. So from I rise 1, run 1, 2, 3, 4, 5, 6, 7. So the change in the Y would be 1, and then the change in the X would be 7. All right, that is simplified, so let's lock that in here. And then looking at R to D, I've got 1, 2, 3, run, fall, 1, 2, 3, 4, 5. Right, so the change in the Y over the change in the X, we're falling 5 and then running 3. So the slope of that would be negative 5/3, and go ahead and lock that one in. And the last one is D to B here. So I'm going to go from B to D so I can have positive values here. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, rise 1, 2. Okay, so I've got 2 is my rise and then 14 is my run. So simplified would be 1/7. Okay, so there we can see here very clearly that since IR and DB have the same slopes, they are parallel, right? You can say that IR and DB have the same slopes and are parallel. And very clearly you can see that the other two slopes are different, right, which would make this shape a trapezoid. Okay, so you can say that BI and RD do not have the same slopes. Okay, therefore, you can say polygon BIRD is a trapezoid. Okay, if you want to get really fancy, you can say because trapezoids have exactly one set of parallel lines. Okay, so then we kind of move on to the next step of this, and it says up here, state the coordinates of point S on DB such that polygon BIRS is a parallelogram. Okay, so what we got to do here is state the coordinates of point S on DB, right? So it makes a parallelogram. So right away, what we need to look at here is if it's a parallelogram, we know that this slope has got to be the same 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. It's got to be the same distance and the same slope if it's a parallelogram. So what I'm going to do is go from R and go backwards. So I'll go left, 1, 2, 3, 4, down, 1, 2, 3, 4, 5, 6. So very clearly, now we have the point S, which is on BD, and the point is 6, 0. So now it is stated. So what happens here now is now we create a new shape, and we want to show that this is a parallelogram, okay? So slopes that we already have BI, all right? We already know the slope of BI from our previous calculations was a rise 6, run 4, and we just kind of redid it, so we already know it's 6 over 4, which is just 3 over 2. All right, so now we want to find the slope of R down to S, and you can see we already counted it already, right? But we can see here that the slope is going to be a rise of 6, a run of 4. So we also have a slope of 3 over 2. So now we can say that RS, another way to write this, RS is parallel to BI, right? RS is parallel to BI, okay? And now the other ones we want to calculate. IR, we already did calculate. We already showed that IR was a slope of, what is it over here? IR was a slope of 1 over 7, right? 1 over 7. So we want to calculate B to S, or S to B. So the change in the Y over the change in the X is a rise 1, run 1, 2, 3, 4, 5, 6, 7, and then there you go, 1 over 7, lock it in. So therefore you can say that IR is parallel to SB, okay? And if opposite sides are parallel, you can say that parallelogram BIRS is a parallelogram. Okay, why is it a parallelogram? Because opposite sides are parallel. Okay, all right, I hope you enjoyed that. Go Birds.